So this is the puzzle we did in class, and my suggestion to you guys is take all these pages and rip all 3 of them out and kind of use them all at once. Now the reason being is that when you actually look at all this stuff, there's a lot of information on here that'll be extremely valuable. The one I like to start with first is actually your elements page, like I had said earlier in class, because a lot of the information on here can give you info about the different blocks. For example, I'm checking and scanning the bottom for any endings in my blocks. So I have a P2 here, I have a P4 in my H, S2s, which mean we have an S1. How high did the P's go? Well, here's a P6. Therefore, when we go actually to our periodic table, we know it's only going to be an S and P block. We don't necessarily know if the P's go first or if the S comes first, so we have to wait and kind of find out. But that's all I'm really looking for right away is how many blocks do I have? I'm going to go ahead and scan my periodic tables for any of them that are in the same family. So A, E, Q, and that the same family, same family, same family, same family. I keep scanning down, These are in the same family, these are in the same period, that'll help a lot later on. And then finally down here we have BX and theta are in the same family as well. Now I'm keeping that in mind as I'm just kind of going about this entire process so that when I figure out where one of these elements go, I can write the rest of the family at the very top. Something I should give you on here is where your metalloids really are, and so your metalloid staircase will exist right here. And all the periodic tables will have a metalloid staircase for you to actually see to help you out with solving your problems. So let's go ahead and take a look at the clues. Besides the family ones, we're going to go all the way through these. So V is unreactive. So if V is unreactive, that tells you it's going to be in the noble gases. We don't know exactly where, but V is going in that location. Now, if we keep that in mind as we're solving this all the way through, that means everyone that's in that family should be in that section. So let's find where V's family is. F, I, P, and mu. That's a 5-member family, which tells you by default A, E, U, Q, and psi are all the other 5-member family or the alkaline metals. So I'm going to cross out those clues because I've essentially used them. What I'm going to do now is cross-reference against my actual periodic table of elements and see if I can get any clues off of where these things should go. So when I look at my elements for V, for example, there's nothing on there that helps me. F, I have an atomic radius, but that's not super helpful because I don't have anything else to compare it to. I have a configuration, and it's a 1-level configuration. So that tells me right away, hey, I is going to go in this spot, and it's also going to be an S2. So you'd think, hey, the S's are probably in this location. But let's just check with the other ones on there. I've used I up, so I'm going to cross it off so I can keep track of what elements I used and which ones I haven't. And so if I continue on, P is actually the 3rd energy level, but it's a P6. So this is kind of weird because there's an S and a P in the same family. However, if you think about it a lot like helium, what you're really seeing is just the S's are over here, but they could technically be over there. So really, this is going to be a P6 block, a P5, a P4, a P3, a P2, a P1, and then your S's are going to be in this location, S2 and S1. Which means if I have a 3p6, assuming there's no orbital overlap, which with only 2 orbitals there probably will not be, your 3rd level p6 should be where element P goes. And we'll double check and see, does mu have anything on it? No, it does not, but I can cross out P and I've already located those 2. Let's go back to our clues. Well, actually at first, let's take a look at A, E, U, Q, and psi. A's got a radius, E's got nothing for us. U's got nothing for us, Q's got a radius, and psi has a radius. So that's not a lot of information. We really can't place those anywhere on there. So let's see if there's a clue on here that actually helps us. The very next clue tells us that E is the lightest element in the entire universe. So by default, E must be the very first element on there. Unfortunately, that's all it gives us because there's nothing else to go along with E, so we need to keep going on with clues. Beyond the family clues, we go down and we say M is the most reactive in its family. Well, right now we don't know which family M is in, so that's not going to be helpful to us. We'll come back to it. U has the lowest electronegativity in the entire universe. Well, the lowest electronegativity in the entire universe should be in the francium location or the very bottom left corner. We cross-reference against our actual numbers on here, and U, there's nothing else on there, so unfortunately that did not help us. But if you remember, A, E, or U, Q, and psi actually had radii on them. And the radius should increase as we go down, which tells us Q is here with a radius of 2.05. Psi is right here with a radius of 2.23, and A is right here with a radius of 2.77. I'm being sure to write all this stuff down so that I can use it as I continue on. And so now I've used that clue right there. I'm going to continue. Mu has the greatest atomic mass in the universe. Well, that tells me mu should be in the very lower right corner because that's where our greatest atomic mass would be. Let's cross out mu. We also have F and V in this family. F has a radius of 1.03. V, there's nothing on it, so that doesn't really help us just yet. We can't write down F and V in that location. So let's continue on. J is more electronegative than W. Again, we don't really know where J and W go just yet, so we'll have to keep going. F has one more proton than J. Well, if we know F is in this family, then J must be in this family, because if F has one more proton to be in that location. So the family that involves right here would be J and everything else that's associated with J. So we'll check our same families, M, W, and lambda. Now that actually helps us because it says M is the most reactive in its family. Since it's in the noble gases, M must be at the very top, which by default puts J down here since it has to have one more, F has to have one more proton than J. It also tells us J is more electronegative than W, so W must be on the bottom. And we'll cross-reference this with all of our spots to see if anything missing on here. And it also tells us in this spot we must have V next to M, and then lambda must be in this location. Now let's cross it against our different elements and see if we have any issues. M had a -1 written on it. That's helpful for us. It also verifies it's in the correct location. Lambda's got a 3p5 on it. That actually lines up perfectly because it's right next to a 3p6. Let's get rid of lambda. J has a radius of 1.12. I'm going to write it in. We don't have anything written down for F just yet, but we'll see if it verifies. And then W, there's nothing written on it. V, we have nothing written down for V, so it's not super helpful, but F, I have a radius of 1.03, which lines up because it actually is going lower as we go across. So we're making good progress, and we've already eliminated a lot of this just by going through about half the families. And we've used J is more electronegative than W. We'd have all of these in the same family, so that's taken care of. We've actually used a lot of clues. So we go about halfway down. Now we have U is the most massive in its family. Now, the problem is we already actually have that placed. It's kind of a redundant clue. We didn't need that. It does actually fall into place there, though, so that's good shape for us because we've taken care of where U actually goes. A, D, and etc. are all in the same period, which means this period right across here should include all of the various elements that are mentioned in there. We do have J and F in there, which verifies J and F are in the same spot. So really, we're looking at D, S, theta, gamma, and delta for the remaining ones on there, which will be helpful when we find out which group they're in. R has 6 protons, so we'll just count the 6th element. 1, 2, 3, 4, 5, 6. That's where R should be. Now what's helpful for that is that, well, R has nothing on it, but we do know the other members of R's family. It should be D, R, T, and star. Now from the clue before, we know that a member of that family should be in the 3rd period along with A. So we have D, T, and star as our options. And if you check, D is one of them. So D must be in this location if it's following that same clue. Continuing on, Y is less reactive than K. Well, right now we don't really know where Y or K go, so that's really not going to help us too much. Going back to the last clue real quickly, D says 4P2 on it, and if you're following your blocks, that would make sense because it's the 4th period and a P2. So we do definitely know D is in the right location. H has many metalloid characteristics. So H is going to be somewhere inside this block. We don't know exactly where, but we'll take a look in a little bit. B wants to lose 3 electrons to be stable. So if you're going to lose 3 electrons, you're going to be in the P1 family. So we know B is going to definitely be there. Well, who else is part of B's family? If we go ahead and take a look, B also has X and theta as part of its family. We'll check and see according to that same period, do theta, oh, theta is actually going to be in that row because that's what it said from that one clue involving the same period. If we cross-reference theta and see if there's anything on there, we do have a radius to write down, 1.81. So we'll go ahead and write that down just in case we need it later on. We don't have any other information in that family just yet, but we did actually use the clue that B wants to lose 3 electrons. Z is the most reactive one in its family. That'll be helpful if we actually know where that family goes, but up to this point we don't. B has the least atomic mass in its family. So that tells you B must be at the top of this family right here. We'll see if there's any information on it. There is a radius of 1.77 for B. And now we still have X left to kind of place in that family, and also an unknown element, it appears right now, because it didn't give us any other information. Q is more metallic than Y. Well, right now we don't know where those two families go, so we'll save that one. B, X, and theta, we've used that clue. L has one less proton than Z. So if we check, Z is not on there, L is not on there, so that's not going to be helpful for us just yet. Within its family, O is lighter than gamma and heavier than L. So up to this point, we're kind of stuck. So we've kind of gone through all the clues, we've written down as much as we can, but we don't really have everything filled out. So here's where you want to check and see, are there any clues from blocks? So we know right away that pi on here is a 5p3. So I go to the fifth level, p3, that's where my pi should be, 5p3, which then tells you the family involved with that is any family that has pi in it. So DRT star, we have that covered already, CHSZ, I'm still looking. It appears as though I can't find this actual family that involves pi. So we'll leave pi alone for now. If we keep cross-referencing with some other elements, let's see if we can find out any other configurations. So far, nothing. K is an S2 in the third spot. So here's our S2, third spot. It's a 3S2, which is nice because we do know some other members of K's family. Because now, if we check for other families on there, anything involving K should fall into that location. So AEU, DRT, FBA, same family, same period. Y is less reactive than K. So unfortunately, K's family is also not listed. So we're going to have to keep going on and take a look at the rest of these things on here and see if we can actually find the other spots. We can also look at oxidation states. So for example, N is a +3 oxidation state. So that tells you N is the missing member of that B, X, and theta family. O is a -3 oxidation state. Well, all these are going to be +1s, +2s, +3s, plus or -4s, -3s, -2s, -1s, zeros, because we have a magic number of 8 in this location. It is possible on your test you may not have a magic number of 8, and you may end up having to count them a little differently. But to this point, it's working just fine for us. So O is going to end up being somewhere in this spot. We can cross-reference and see, are there any members of the family that has O in it? And if we look down here, I have a feeling there won't be. Based off of the families, no, but we have this. Within its family, O is lighter than gamma and heavier than L. So within this family, which already has pi listed on it, O is lighter than gamma, but it's heavier than L. So O must be in this location, as a -3 written there. It is lighter than gamma, so gamma needs to go in this spot. We'll cross-reference with gamma. It has a radius of 1.33 on it. And it's heavier than L, so L must be in this spot, which has no other information on it. So we've used that clue. L has one less proton than Z. Well, now that tells us that Z must go there. Z has nothing else on it. However, we do know the members of Z's family are C, H, S, and Z. So if we check that, we can go back and say, okay, are there any other clues that involve C, H, S, and Z? It does say H has many metalloid characteristics, which means it must be in this location in the bottom corner here. It also makes sense because its configuration is a 5p4. So that fits. The other members of that family, S and C, have no information on them except for S has a radius of 1.22. Now, that would make sense so far in really either location that we're looking at, so we can't use that just yet. So we'll leave C and S alone for right now, and we'll go back and check our clues. As we're scrolling down, you want to double check and see, okay, the third period, we need to have A, D, F, S. Well, that just told you where S went. S has to go in this pot because of that same period spot on there. Now S is a -2, it has a 1.22 radius, which makes sense because it is going down as you go across. Gamma was also shown on there, which tells you that this one right here must be delta. And delta has a radius of 2.23. So we're using all the information. We've now used everyone that's in that same period, and that entire period is calculated across. Y is less reactive than K. Well, up to this point, we have K right here. So if Y is less reactive, if we cross-reference on Y, there's no information listed on it. However, if it's less reactive than it, it must be in the same family. And if it's in that same family, Y must be at the very top, which makes it take care of that clue. H has many metalloid characteristics. We've taken care of that. Z is the most reactive one in its family. We've taken care of that. Q is more metallic than Y, which puts Q at the very bottom down here as being more metallic. If we cross with Q, it's got a radius of 2.05. So if we keep moving on from there, we're going to go ahead and place the rest of these elements based off of everything else we have. L has one less proton than Z. That's taken care of. And so now if you look at it, it looks like we've used every single clue on here. And so you'd say, well, what else do you do? Essentially what we have to do is basically place the rest of the elements on here based off of radius and where everything should go. So if we check, we've used A, we have not used C, we have not used G, we haven't used N, but we know N goes somewhere inside here alongside with X. S, we know it goes in that location, so we've used S. T, we're not sure exactly where it goes, but we know T and star go in somewhere in these spots. X, we haven't used just yet. Y, we have just used, so that's placed. So we have star, psi has actually been placed, and delta's been placed. So of the locations here, we have 4 elements, or 5 elements left. It should be C, G, N, T, star, and X. X and N are going to be in these locations. Star and, what do I have left? T are going to be in one of these 2 locations, and it tells us what should go in this spot now. Should be C, because it's a missing one left from that period, or left from that family. So now it comes down to, okay, well, how do we place these things on here? Star has a radius of 1.98. D has a radius of 1.52. So star must be in this bottom location if it has a radius larger than T, which is in the same family of 1.52. Okay, well that takes care of those 2. And now we go to N and G, and we have to take a look and see, okay, where are these things actually going to play out? And we'll double check and see if there's any clues that involve N and G that we've accidentally crossed out that we could have used. And as you're going through, you'll take a look and you'll say most massive. No, nothing with N and G specifically. N does actually have a radius on it. Now, the reason why we can't put N here is because then the radius would go 1.77, 2.01, 1.81. That doesn't make any sense. So N must be in the bottom down here, a +3, a 2.01 radius, and therefore X must go in that spot, and we finish the entire periodic table, and we can check it against the key.